black holes. It's not just the stuff of science fiction. For years, the mysteries surrounding black holes have been tugging at scientists and researchers. But truthfully, we have barely begun to scratch the surface with what little we know. Generally, a black hole is described as a region in space and time that has such a strong gravitational pull. So strong, in fact, that nothing, not even light, radio waves, particles, and radiation can escape it. Because of this strong gravitational pull, scientists and the best of Earth's technology still cannot directly observe a black hole. So how are we able to observe it? Well, scientists indirectly observe the particles and radiation that are being drawn into the black hole. So where do black holes come from? Scientists theorize that black holes are formed when a star collapses in on itself. When this happens, the star's mass becomes densely packed, and this exerts a very strong gravitational pull. This strong gravitational pull then starts to attract nearby space objects like dust and other space particles, which contributes to the growing size of the black hole. Scientists have identified two layers of a black hole based on what can be observed here on Earth. The first layer is called the event horizon. This is the point in the black hole where light can no longer escape. Meanwhile, the second layer is called the singularity. The singularity is the point where all of the mass of a black hole is concentrated. Black holes come in a variety of sizes. The smallest type of black hole is called the primordial black hole. Scientists believe that this type of black hole is as small as a singular atom but has the mass of a big mountain. On the other hand, a stellar black hole is considered as the medium-sized black hole. Stellar black holes have a mass that can go as 20 times greater than the mass of the Sun. Many stellar black holes can be observed in the Milky Way galaxy. The largest black hole is called a supermassive black hole. These black holes have a mass that is larger than the mass of 1 million suns. Scientists think that each large galaxy has its own supermassive black hole in its center. The supermassive black hole of the Milky Way is known as the Sagittarius A. So, is the Earth and the solar system safe from the threat of a black hole? Currently, there are no known black holes observed in the solar system. Hypothetically, however, if the Sun would collapse on itself, the resulting black hole's gravitational pull would have to be greater than that of the Sun for it to be able to attract nearby objects in the solar system. Otherwise, the planets would just revolve in orbit around it. Olympus Mons. Today, let's talk about a particular landmass on the surface of Mars. Mountains, volcanoes, and other surface features are not just exclusive to Earth. Let's just say, if the Earth has Mount Everest, then let us introduce you to Mars's Olympus Mons. Olympus Mons is not really a mountain per se, but it is actually a very, very large shield volcano on the surface of Mars. It has a height of 22 kilometers or 13.6 miles. That's almost as tall as about 2.5 Mount Everests on top of each other at above sea level. Currently, it holds the record as the tallest mountain of all the planets in the solar system. Olympus Mons takes its name from the Latin form of Mount Olympus, or the mountain where the gods of Greek mythology lived. Scientists think that Olympus Mons is the youngest of the large volcanoes on the surface of Mars, formed sometime 3,700 million years ago, in the year scientists call the Hesperian period. A period in time on Mars characterized by widespread volcanic activity and catastrophic flooding. Olympus Mons can be found in the Tharsis Montes region of Mars. This region is roughly near the equator of Mars. Olympus Mons is one of the many volcanoes in the area. For comparison, here's how big Olympus Mons is when compared to some popular land masses on Earth. It has a height of 22 kilometers or 13.67 miles. Meanwhile, back here on Earth, our tallest volcano, Mauna Loa in Hawaii, is only 10 kilometers or 6.2 miles high. Olympus area stretches across 624 kilometers or 387.87 miles, which is almost as big as the US state of Arizona. Olympus Mons is classified as a shield volcano. This type of volcano has a low slope, giving it a shield-like appearance. Shield-type volcanoes are the result of lava flowing down on the volcano's sides. At the summit of Olympus Mons is a depression that measures 85 kilometers or 52.8 miles wide. But how can such a tall volcano form on Mars but not on Earth? Well, scientists think that it has to do with the lower surface gravity on Mars, combined with the higher rates of constant volcanic eruptions in the surface of the planet. This allows the lava to pile up higher on Mars. Scientists also think that the limited tectonic plate movement in Mars also plays a role in the formation of such gigantic land masses. On Earth, the tectonic plates move underneath the crust, limiting the steady buildup of lava, while on Mars, the limited movement of its plates allow lava to steadily pile up on the same place, thus forming taller land masses, such as the Olympus Mons. Jupiter, the fifth planet from the Sun, coming in with a diameter of 142,984 kilometers or 88,846 miles and a mass of 1.90 times 10 to the 27th power kilogram or 4.184 times 10 to the 27th power pounds. With 67 moons, 4 rings, and an orbit period of 4,333 days, just a little shy of 12 years, with a temperature of approximately -148 degrees Celsius or -234 degrees Fahrenheit. It's a gigantic planet with a great red spot. Welcome to Jupiter. The planet is named after Jupiter, the Roman god of thunder, who is considered the king of the Roman gods. The Romans, however, were not the first to discover the planet. The ancient Babylonians were the first to write about Jupiter around 7th to 8th century BC. Because of its large size, other ancient cultures also named Jupiter, the planet after their ancient gods. We have the Greek Zeus, the Mesopotamian Marduk, and the Germanic Donar or Thor. The planet is known as a gas giant, which means that it is mainly composed of gases. Jupiter is made of layers of gases that are composed of various elements, among them ammonia, sulfur, and hydrogen. Its interior, however, is a different story. It is composed of compressed hydrogen gas, liquid metallic hydrogen, and a core that consists of ice, rock, and metals. One of the most striking features of Jupiter is the Great Red Spot, a visible red spot that is actually a huge storm that has been going on for almost 350 years. To date, there have been 8 man-made spacecrafts that has passed by Jupiter. These are Pioneer 10 and 11, Voyager 1 and 2, Galileo, Cassini, Ulysses, the New Horizons missions, and most recently Juno. International Space Station. Imagine nations coming together to create one of the greatest scientific marvels of the century. A habitable spacecraft in Earth's low orbit. Seems like a good theme for sci-fi, eh? Well, it does exist. Enter the International Space Station, also known as the ISS. A product of the collaborative efforts of governments, scientists, and engineers from all over the world. The ISS is an artificial satellite that is also a livable space station situated in Earth's orbit. It was made by launching modular segments from Earth, which were then connected and assembled in space. The ISS is also the largest man-made body that is circling in Earth's low orbit at an altitude between 330 to 435 kilometers, or 205 to 270 miles. The International Space Station completes an approximate 15.5 orbits in one Earth day. It serves as a space observatory and a lab where astronauts and scientists can observe Earth at low orbit and perform various experiments in a low-gravity environment. It is also a place for astronauts to stay and train for longer missions in space. Aside from these, the space station also serves commercial, diplomatic, and other educational purposes as well. In the future, the space station may be used as a port or station for manned missions in space. The ISS is an international joint project between the space agencies of the following countries: United States NASA, Russia's Roscosmos, Japan's JAXA, Europe's ESA, and Canada's CSA. The ISS was first launched in 1998 aboard a Russian spacecraft. More pieces were then added, and the space station was ready to be used come November of 2000. The space station has been in use since. The space station also continuously receives new modules, supplies, and parts from Earth. Inside the space station is approximately the size of a 5-bedroom house. It has 2 bathrooms, a gym, and a large bay window, and it weighs in at about 1 million pounds, or 453,000 kilograms. The space station consists of many parts, which are called modules. Each module has its special function, such as life support, communication, navigation, living quarters, and others. Modules are connected to each other by nodes. The ISS is powered by solar arrays, which collect energy from the sun and turn this into electricity. Outside the space station are robotic arms that are used for a variety of tasks, such as builds, repairs, and even moving astronauts outside the space station. There are also airtight doors called airlocks. These function as entrance and exit points for the astronauts. And finally, the space station also has docking ports to dock and connect spacecraft to the space station. Cargo and crew are flown to the space station with the help of the Russian Soyuz spacecraft. Lightyear. Space. It's so vast that it defies our concepts of near and far. Imagine, for example, the Earth's moon, one of the closest astronomical bodies near our very own planet. You could say that it's near, but how near is near? That's 384,000 kilometers, or 238,855 miles on average. How far is that? Well, it's the distance of 30 Earths side by side. Now imagine Alpha Centauri, the nearest star system next to our own solar system. It's approximately 41.32 trillion kilometers, or 25.6 trillion miles away from Earth. Now that's far. So how do astronomers measure such great distances without having to write exceedingly long numbers? Well, here's one way of measuring astronomical distances called the light year. The light year is defined as the distance light travels in a year. So, if light travels at the speed of 299,792 kilometers per second, or 186,282 miles per second in a year's time, that amounts to a distance traveled of about 9 trillion kilometers, or 6 trillion miles. At first, it might be a little bit confusing to some, because of the way light year is named. It's important to take note that the light year is not a measure of time, but rather a measure of distance that so happens to be the distance that light travels in exactly a year's amount of time. The light year was first used by Friedrich Bessel in 1838. He used it in an article he wrote about the distance of the star 61 Cygni. At the time, the favored unit of measurement for astronomical distances was the astronomical unit, or AU. The AU was based on the radius of the Earth's orbit, which is 1.50 times 10 to the 8th power kilometer, or 92,955,807 miles. Using this measurement, the distance of 61 Cygni was calculated to be at 66,000 astronomical units, or 9.9 times 10 to the 13th power kilometer, or 6.13 times 10 to the 12th power miles. To illustrate how far that was, Friedrich added a little trivia for his readers. Light takes approximately 10.3 years to travel that distance. Friedrich refrained from using it much though, because the speed of light was yet to be a determined constant at the time. In 1951, however, a German by the name of Otto Uhle used the light year in his articles on astronomy. Today, the light year is used to express great distances between stars found in a general area. Modern astronomers, however, prefer to use the unit of measurement called parsecs, the distance where one astronomical unit subtends an angle of 1 arc-second, or 648,000 over pi astronomical units. Food in space. Now picture this. You are in space with zero gravity, then suddenly you feel hungry. It's a given if you're traveling far away, you will need to bring food with you. That being said, let's take a look at some considerations when taking food into space. It should be compact enough. It should have a long shelf life. It should be manageable at zero gravity. And of course, it does help if it tastes good. In 1962, astronaut John Glenn was the first human to ever eat food in space aboard the Friendship 7. Scientists weren't even sure at the time if digestion was possible in space at all. Space food of the 1960s was based on US Army survival rations. This consists of pureed beef and vegetables packed in aluminum tubes that look very much like toothpaste tubes. The next development in space food came with the Gemini space program of the mid-60s. This type of space food utilized freeze-drying, where Earth-prepared food is flash-frozen after cooking and then heated to remove moisture and water content. The food is then vacuum sealed and packed.